a joint venture with Mr. Prowler, also consults on architecture, or two architecture firms, on issues of thermal performance and daylighting. Quoting from his biographic sketch that I received, in his teaching, research, practice, and writings, Mr. Prowler has consistently explored the relationship between technology and architectural form. From this perspective, he has concluded that that architecture can be best characterized as the mediation of the interior from the exterior and of the past from the future. Consequently, he feels obliged to spend as much time interpreting the future as many seem content to reinterpreting the past. He has a recently published book entitled Modest Mansions, which is the title of his address this evening, although he informs me that it would be better titled Metal Mansions. Please join me in welcoming Donald Prowler.
Thank you. It's a rather difficult room to talk in. It's like a moat between us. I'm going to take off my coat because it's getting warm here already. 1 minute. We could go right to the slides. I have to hit the buttons. When I was asked to come here today, I had a choice of different topics I could speak to, but it seemed as a invitee, partially under the auspices of the center here, that rather than show my own work, I might show a piece of research which will eventually lead to some new work. It's a piece of research which we're actively engaged in now, which I think is many lessons, not only for research and case study on how to proceed in architectural research, but also for architecture in general. So I'm trying to convince you today that all those things are related. And it's also a detective story. I think you have to look upon it as a detective story in progress. So as you see the facts of the case unfolding for you tonight, if when I'm finished at the end of this evening, you know the conclusion, please come and tell me, because I don't yet know it. The story starts about a year ago. I was sitting in my office at University of Pennsylvania, and I received a call from someone who introduced themselves as being from Bethlehem Steel. Bethlehem Steel, of course, is the second or third largest American steelmaking company, and their headquarters are in Bethlehem, Pennsylvania, about an hour from Philadelphia, and we are the closest architecture school. This gentleman said to me, we know that you're interested in architecture and you're interested in thermal performance of buildings. And we were sitting around here up at Bethlehem going bankrupt, and it occurred to us that steel isn't used very much in houses, and that there ought to be some way we can apply steel to housing. And we thought that you might help us design a prefabricated, energy-efficient steel housing system. And I was being told this, and I couldn't believe my ears. It was so deliciously out of style to be worried about prefabrication in 1985. What could be further from the interest of most architects in 1985? So I was immediately totally interested in the idea. But that was the total charge that we were given. That was the sum total of what we were told to do. We were given a budget, and they said, okay, figure out more ways to use steel in houses. And it's probably something to do with the prefabricated metal housing system. Well, I knew, having read my history of architecture, that had been tried many, many times before. I know that prefabrication had been tried many, many times before, and I knew that steel in prefabrication had been used many times before. So I didn't want to immediately start reinventing the wheel. So the first thing we did is look at what had been done. And to a great extent, what had been done fits in very closely with the history of architecture over the last 60 or 80 years in this country and in Western culture in general. The first thing we found out was that just about when we started this work, about a year ago, a book had been published by MIT Press called The Dream of the Factory-Made House. And it was a book about the work that Walter Gropius had done with Konrad Wachsmann in the field of prefabrication, and specifically, not specifically, but partially metal prefabrication. So immediately that was interesting, because Gropius is certainly a pivotal 20th century architecture figure. And if you know your history, you probably are aware that for Gropius, prefabrication was a major issue. Because the modern movement, the international style, as it came to be practiced, was really an idea about architecture. It was about using machines, applying it to architectural production for the improvement of culture in general. And in that quest, it did certain things. And one of the things it did was reject eclecticism, and it rejected historicism, the kinds of ideas that we're looking at much more closely now, largely as a response perhaps to that over-exaggeration of that early modern movement impetus to not look at those things. But as good architects, as good designers, there still had to be some ordering system. There had to be some philosophy by which buildings were put together. And if we were no longer looking at classical orders or the symmetries of classical architecture, we had to look at something else. And for Gropius, what we would to look at was the syntax of the machine and the syntax of prefabrication. That somehow in these kit of parts, you've heard the expression, I'm sure, in architecture schools many times, the kit of parts, the idea that somehow you produce these objects, and there was a way they went together, and in that syntax, there was enough order to make architecture. But it would happen individually. Each architect or person would use that kit of parts and make a personal expression. So Gropius had, by 1910 in fact, while still working for Peter Behrens in Berlin, had written an important paper where he had described for the first time this notion of a kit of parts. And we'll see how that 1910 paper will affect us today in 1985. Well, we looked at the book by Herbert, The Dream of the Factory-Made House, and many other sources, and we found that, much to our surprise, there's an enormous history of metal prefabricated houses. The one on the left is from 1925. It's an English system called a Telford house, and it used metal plates flanged with flanges that are bolted together, and the metal plates became the exterior bearing wall of the house. The system on the right is a Forster and Kraft system from Germany from about the same time. This actually is a picture of the United States patent that they applied for in 1930, but the system had been worked out in detail about 5 or 6 years earlier. In this system, rather than having metal plates flanged together that are carrying the load of the wall, here we have on the right, in the German system, a series of panels. Each panel has a frame, a wooden frame, and what you're seeing there, that facade that looks like it could be out of Michael Graves, is really a copper sheet that has been crimped and is the outside layer of this panel. So you would have all air spaces set up by these multi-layers of copper. And the idea was that it was to be energy efficient. I did point out, I think, but I should emphasize that one of the criteria for the system was that was the system we were to design was that it be energy efficient. So we were also looking at energy efficient details. But as an architect, I wondered what it was, because every prefabricated house I thought I had ever seen had not appealed to me. So I was wondering, what it could look like at the same time. We should talk for a moment about prefabrication in general. Almost every house built in America today is prefabricated in some sense. About 95% of all the homes built in America use prefabricated roof trusses today, 95%. About 60%, believe it or not, use prefabricated floor trusses. And a good percentage of them use prefabricated stairs and other components. So almost every house in America is prefabricated. So in that sense, there's absolutely nothing new about the notion. But what about metal? Well, let's see. So we see in the 20s, in England, metal houses. In Germany, metal houses. There were about 3,000 produced in England. And the reason they were produced at that point in the 20s was largely as a response to the housing shortage of World War I. Metal housing has traditionally been seen, or prefabrication in general, is oftentimes stressed in times of special needs for housing, such as after wars or during crises. That's just a picture of Gropius. After the 20s work in England, the focus is really over to Germany. There are many at least 24 companies that manufactured some versions of metal prefabricated houses. Typically, the system consisted of panels with exposed metal, steel or copper, and the problem was that for the most part, they didn't maintain very well, and they were also selling at a premium. So this idea that somehow things could be cheaper wasn't seeming to work out. But by the 30s, Gropius was a very major figure in Germany as an architect and in architectural education. People knew of this idea of the kit of parts, and it was an idea that people like Corbusier, Mies experimented with in their own personal elaborations. So you have Mies doing the Barcelona pavilion, you have Corbu doing Maison Domino in poured concrete, of course, in that case. But the idea of prefabrication, the idea of mass housing was very much in the air. Gropius, in the 30s, went to work for a major copper company in Germany called Hirsch Copper and Brass. And that Hirsch company had purchased the design rights to the system I showed you previously on the right-hand screen, the Forster system. And Gropius redesigned the system. So he started with that basic idea of the frame, the wood frame, and the copper sheets, and redesigned the system to look like this. This was a Gropius design for a case study copper metal prefabricated house. Once again, you can see barely, I'm sure, not too well. This is the worst slide. They get easier to read after this. There's a wood frame and sheets of metal. This was about 1932 in Germany. At that time, in Germany, during that decade, there were about 10,000 or so total metal houses, mostly copper, some in steel. With the Depression and ultimately with World War II, that whole industry ceased. There's some houses still around, but they're hard to find. While that was going on in Germany, there was a different tradition going on in the United States. If you can imagine on the left, what you should be seeing is a slide of an Airstream trailer. But I didn't have a slide of an Airstream trailer, so this is the best I can do. In 1936, Wally Byam innovated the first Airstream. And when he was designing the Airstream, he was looking mostly at aviation technology. At the same time, when Fuller, on the right, in his Demaxion house, this design is from the 40s, but the idea started much earlier, he was looking at automotive technology. The idea was basically phrased, well, if Detroit can produce all these cars, why can't we produce houses in the same way? Why can't we produce ourselves into the future, residential future? So the American prefabricators, people who were thinking about prefabrication as an architectural idea, were looking more towards the transportation industries, the cars or airplanes. Whereas Europeans harp back, Prouvé, Corbu, Mies, and the others who were thinking about it at all, were looking back at Gropius' idea of a kit of parts. And I think we'll see how that's affected the progress in thinking about prefabrication since that time. The most famous case of the metal prefabricated house, the one that many of you might already know, is the Lustron house. The Lustron house got some publicity about 3 or 4 months ago by a major article in Fine Home Building magazine. Some of you may have seen that. The Lustron house was a system that was devised right after World War II. During the war, as you would suspect, there was an enormous housing shortage. And as soon as the war was over, veterans coming home, there was a need to find about 3 million houses in the space of 2 years. And up until that point, the American home building industry had produced nothing like those numbers of houses. So what were we to do? Truman, at that point, placed into the Veterans Administration someone by the name of Watt, not the same Watt of more recent eras. But Mr. Watt was a great believer in prefabrication. Not only was he a believer in prefabrication, he was a believer in metal prefabrication. And what he did was he gave guaranteed contracts, or at least attempted to give guaranteed contracts to a certain number of housing systems to get them off the ground. And he was also trying to get them loans through other branches of the government, particularly the Reconstruction Finance Corporation. So in 1946 and 1947, he was looking for metal prefabrication companies to come to him, and he would set them up. And his favorite was Lustron. Lustron was the brainchild of someone gentleman by the name of Strandland, who before the war was selling porcelainized panels for uses in primarily in garages, those square porcelain panels you see. But it was his idea to take that enamel steel panel technology and apply it to a whole house system. And he was such an aggressive person, apparently, and such a good salesman that he was able to get $50 million from the government, free dollars from the government, in 1947 dollars. So it's probably an equivalent of $1 billion today, or at least $500 million, to establish a factory in what had been a surplus war factory in Columbus, Ohio. And the Lustron houses came out of that factory. The houses are an example of several of them lined up or on the right. They were fully steel houses, steel roofs, and these square, 4-foot square porcelain enamel steel panels on the exterior. One house would fit on one truck. You would buy your house, it would fit on the truck, it would go right to your site. The truck, once it was at your building site, would be used as a construction trailer for the rest of the operation. So as pieces came out, that would be used as an office. And at first, the first go-round, when they first developed these houses, there were about 3,000 separate pieces that then had to be assembled on the building site. By about 1949, Lustron was fully operative, the factory was fully working, and they were pumping out houses at the rate of 4 houses per hour. The plan of a typical Lustron house is shown on the left, and an example of a Lustron house is shown on the right. And it's oriented the same way as the plan. So what you're seeing is a little porch on the bottom on the left, living room. Most typically, they were 2-bedroom units. They were, in the end, before Lustron went bankrupt in 1950, they produced about 4,000 houses. And they can be found all over the Midwest and the East. And many of you probably have seen Lustron houses. There may even be one in Muncie. Does anyone know, is there any in Muncie? There's 2 or 3. Almost every town in the Midwest has 2 or 3. This one is in Allentown, Pennsylvania, but any place you go. And the owners of those houses usually love them. I mean, there's a real cult following. It's like the Rocky Horror Show of houses. And they are magnificent designs. When I first looked at this, I kind of wrote them off as architecture, but as I got to look closer and closer, I found them to be exquisitely detailed. These were very bright people, and let's look at some of the details. Well, one of the first things you can see, the column that's supporting the porch actually supports a little trellis, but not only is it that, it is actually the gutter. So all the rain comes down through that column. So it's simultaneously structure, rain removal, and a place to support a vine. And that's just a little detail. There are many, many, many others you'll see. This is the rear of a typical 2-bedroom Lustron house. It came in different colors, about 5 different colors, and you just walked in and you picked which color you preferred. And they're so wonderfully postmodern colors now. They must have gone out of style somewhere in the 50s and 60s, but they've come back and they look sort of nice mauves and colors like that. This is an isometric of that 2-bedroom plan, slightly out of focus. There you go. But shows you the house oriented in the same way. So you see the rear door, the kitchen's on the right, and the 2 small bedroom windows on the left. Now, one of the big problems you run into with the idea of using a metal prefabrication system, particularly if you want it to be energy efficient, is what do you do about keeping the heat in? And Lustron had thought about that even then. They have steel studs, but they're not the steel studs of the more traditional kind of steel stud construction we see today in some construction. They were steel studs which were non-continuous. They were crimped sections, and there would be a channel, and they would alternate slightly on either side of the channel, so you were able to put insulation continuously between the studs. It also gave you a place to run plumbing or electrical wires, as you can see on the right. The panels themselves, you can see illustrated on the drawing here on the left, they would overlap and they'd be screwed to that channel. There was a little space within that crimped channel, and the screws would go right into it. So very tightly screwed in place. I've visited about 8 or 10 Lustrons, and in most cases they're in wonderful shape. They're almost as good as new. In some cases, there's a little rusting going on. And if there is some rusting going on, most of the owners have just kind of patched over it. In one or two cases, owners have had trouble, maybe someone's backed a car into the house or something like that. They typically take car compound and fix it as if they were fixing a fender. Another interesting phenomenon, I'm not a sociologist by any means, but I've noticed that whoever owns a Lustron house buys a car the same color. So they park the car in front of the house and they wait for people to take pictures. I think also the way it was marketed in 1949 was wonderful. They showed these pictures of people in lab suits with hats putting up these houses. When's the last time you saw someone on a construction site with a hat on like that or a lab suit on? But it worked very well. They were enormously popular. They couldn't fill the orders quickly enough. And again, elegant details. Look at that little beam that spans the window opening. It's a little truss, elegantly engineered. The roof truss itself is steel, and it used a radiant heating system. Hot air would be run through ducts, which were on the bottom cord of that roof truss. So it's a radiant ceiling, one of the first prefabricated houses to use that system. And most of the Lustrons I've been to still use that system today. I really love the detailed little truss over the window. Elegant. And here you can see a panel being put in place. It would just be interlocked as is indicated and screwed to the frame. Magnificent detailing on the windows. Just wonderfully pregnant shapes on the moldings. Once again, very modern. I mean, I've seen that in some Michael Graves drawings in the last couple of months. But there it's from 1949. And you can see the 4-foot panels there. Here's a couple of shots of some more Lustrons. I point out to you that the roof is steel as well. Maybe you can see there's 4-foot centers. Excuse me, these exterior panels are 2-foot squares. I said 4-foot. The roofs are 4-foot. So you can see maybe every 4 foot there's a little seam. So it's a steel truss and steel, painted steel shingles on top of it. Now all of these houses you'll see, none of these have been painted or at all modified since they were built about 40 years ago. The insides are period pieces, again metal insides. One of the questions we had when we first started thinking about metal houses was, would people accept the idea of metal on the insides of houses? And we are still not sure, but at least they did for Lustron. So what you're seeing is, again, 2-foot or 4-foot panels which are fluted, just to give it a little more decoration, and 4-foot ceiling panels on the inside ceiling. Rubber gaskets between panels, and a beautiful shading system. Part of the system, you would buy it with your house. It was an option like air conditioning or a cigarette lighter. And it was spring-loaded. So you would pull down this cord and your awning would come down in the summer. Well, Lustron was very famous in its day, and it's very famous recently as a result of that fine home building article. Less famous were some of the other companies that same person, Wyatt, supported in late 1940s. The second most famous company they supported was the General Panel Corporation, which was in fact a company that Gropius and his friend Waxman were seminal in putting together. The General Panel Company idea will harp back to those systems that Gropius was playing with in Germany. It was again this kit of parts. It was the idea of designing a panel with a universal joint, so this panel could go together in innumerable configurations, and that the designer or the homeowner would be responsible for making the architecture. They were trying to optimize the piece, not optimize the whole design. Lustron was trying to optimize the whole design. They weren't selling pieces. You couldn't buy a Lustron panel or Lustron truss. You bought a Lustron house, and you bought it in one of 5 colors, and that was that. That was not Gropius. Gropius was selling you a kit. He wanted you to buy an erector set. So he was really concerned about the pieces of that erector set. And they drew millions, at least, I'm told, designs for how that joint could go together. But they too were successful in getting money from Wyatt. They got, I think, quite a bit less. I think it was $8 million. Still, in 1947 dollars, that's a lot of money. And they too put together a whole factory. Theirs was in California. The Lustron factory was in Columbus, Ohio. And once again, their system was designed to all fit on a truck and be sent to the site. But they were sending pieces. Lustron was sending houses. The panel itself was designed around a wood structural frame, like the old German systems, and a stress skin plywood construction. So it was not steel, except the connector was a cadmium die-cast metal. And it was quite elegant. But most of the panel was wood, the stress skin construction. General Panel managed to fabricate about 400 houses before they went bankrupt, just about the same week that Lustron went bankrupt in 1950. Because what had happened to both those companies was that by 1950, the housing shortage was essentially over. Traditional house construction had caught up with the demand, and they no longer had a captive market. They had to compete with traditional stick houses. And they found that their houses, because they cost a little more, you had to pay a premium, couldn't compete. And they had borrowed so much money from the government that they just could not pay that huge capital expenditure. So we learned something about the marketing of these products from looking at their demise. But it's an amazing joint. The system of panels they came up with are shown here on the left. There was about 10 panels. Some of them were opaque panels, some were window panels, some were door panels. They each had 4 of these universal connectors, and you can see on the right the various ways in which they could go together. They could be an exterior corner, an interior corner, they can be a partition wall corner, all sorts of things. I love this magazine cover from 1947. And I think it's interesting to realize that in looking at the original sources for much of this data in the 40s, that's what the architecture magazines were writing about. The PA, Progressive Architecture Award winner in 1949 was a prefabricated housing system. If you did that in 1986, there'd be a revolution. If you looked at the covers of the magazine, they were showing Gropius's joint. So it's interesting to see how the ground zero in architecture has shifted since that period. Here are some pieces of the general panel system laid out on the ground, waiting for assembly. And here is a general panel house on the left and an isometric of the system on the right. There were several houses built in Queens, New York, and the rest, most of them were in California. So it's unlikely that you will have seen one of these. While the whole idea, Gropius's whole idea, was to sell this kit of parts, it became all too obvious by late 1949 that no one was buying the idea of a kit of parts. So Gropius quickly designed some houses. And these are the renderings that Gropius did for the advertising brochures for those houses. One interesting thing in doing this research and finding out about these houses, we did have to go to the original sources because not much has been written about these, really. And one of the places where something has been written is a book on prefabrication called A Crack in the Rearview Mirror. Some of you may know that book. It was published in 1972, and it's fairly well known. And there's a chapter in there about Lustron. And we read it dutifully. And then we went to look and did our own research. We found that it didn't jive. There were mistakes, not big things. Dates, numbers were wrong, and so forth. And we thought, we should check this out for the sake of history, get this right. So we went to call the author, and we noticed at the end of this chapter in that book, I won't tell you who the author is because he's dean of a school of architecture, and I don't want to get on his bad side. But on the end of this chapter, it says written by a different person and presented as a paper at Berkeley in 1972. And I looked at the name, and it seemed vaguely familiar. But I didn't think about it again until I found these inconsistencies. So I said, I better find this person. Couldn't find them. I called Berkeley. I assumed he was a faculty member there. No such person. So we looked at the AIA directory of every living American architect, and this person's name showed up living in Albany, New York. At which point I remembered that I had once done a commission for someone in Albany, New York, and I worked with a local architect, and this is who it was. And it never occurred to me it was the same person, but this person was younger than I, and this article was written in 1972, and it didn't make sense, so I called this person up. I said, are you this person? Do we know each other? And he said, yeah, we work together. I said, can I ask you something about your lustron history? He said, what are you talking about? I said, well, you know, you are the lustron authority. The Fine Home Building article quotes you. The book on Gropius quotes you. Your book is the standard reference. He said, what are you talking about? He said, that was a student paper I had handed in for a homework assignment. I never knew anyone published that. It's full of mistakes. He never had seen the book. So if you look at lustron history, it's printed incorrectly in many, many places as a result of that one article. So we knew about general panel, we knew about lustron. We found one other system that was very interesting to us as Philadelphians. One of the companies that was awarded a grant was called the Harman Company. You've never heard of that one. They never got anything more than one prototype built. But the architect of that prototype was a guy named Stoneroff, which is a well-known Philadelphia firm whose primary designer was a guy named Louis Kahn. We found the prototype house, and we think it's very likely that Louis Kahn worked on this metal house. So we know maybe what a Louis Kahn metal house might look like. We haven't published that one yet. We're going to saving that for a magazine. So we learned about that history. Then we kept going because there's much more. In the 50s was the introduction of the steel stud. Steel stud you've all seen in construction. But as an idea about using steel in houses, it's really very strange. Because what you're doing is you're taking steel sticks and replacing wood sticks with steel sticks, which to me makes, at least conceptually, very little sense. I know that there are lots of reasons why one would want to do that. But as an idea about steel, it didn't seem to be a good one. Nevertheless, steel studs in residential construction are becoming slightly and gradually more popular. These are just some details of steel studs. The first steel stud was introduced in the late 50s for interior walls and in the 60s for structural bearing walls. Our benefactor for this research, Bethlehem Steel, had even jumped on the bandwagon. They had designed a system called Mode 1, which was a steel stud system which had snap locks, you didn't have to screw it together. It just snapped together like an erector set. It would all come pre-cut right on the site. And they marketed that briefly in the early 70s, but just about the time they were marketing it, the price of wood dropped and they were no longer interested. It didn't compete. Just some examples of the detail from their Mode 1 system. And many, many companies, US Steel, almost all the steel companies, many other US Gypsum, other companies, came out with some version of steel studding. And they all promoted it as a new steel house idea. But basically, they were all just building steel sticks. And sometimes when these were put in houses, you got very uncomfortable relationships of materials. I mean, this is a detail of the Mode 1 system where you still need wood to frame the opening, and you stuff fiberglass in there. And then you sometimes had to glue plywood to the metal, so you had to use adhesives. Just, again, the conceptual problem I have with using steel sticks. But it did snap together. The slide on the right and the left and right really are quite funny, because when the Bethlehem people were telling me about this work, they were so proud of their steel houses, and they showed me these two slides, and I said, where is the steel? I mean, it's basically a wood house with a couple of steel sticks stuck in it. They probably the house would have stood up without them. It's not surprising that it didn't lead to much. Then came Operation Breakthrough. And some of you may remember it, faculty. It was an attempt in the late 60s, 69 it was initiated, to bring prefabrication, to bring systems building to the fore. Most of the proposals under that program were for multi-family, high-rise, and middle-rise construction, many of them precast concrete designs. Remember in those days you had Moishe Softy doing Habitat, you had Habraken at MIT talking about supports. There was something in the air about this idea. And it became, in the end, so phenomenally unsuccessful that if by the 70s, if you wanted to squelch something in architecture, all you had to say was, it's another Operation Breakthrough. And people would immediately look in the opposite direction. Because while there was a lot of proposals, a lot of ideas, very little in the way of actual buildings came out of it. At least we look at it now and say that. in fact, there were some technologies that came out of it in prefabrication and in precast concrete and so forth, but the perception is that it was largely a failure. Most of the proposals had to do with either modular housing, where you're making three-dimensional elements and placing them, or panelized housing, where you're making two-dimensional elements like walls in a factory and then erecting them together at the building site. And you'll see that the system we're going to propose for Bethlehem is neither of these. Following Operation Breakthrough in about 1974, there was another attempt at a metal prefabricated housing system called the Ilzro House, I-L-Z-R-O. At the time, it was heavily advertised in the industrial magazines, Popular Science, metal magazines, but not the architectural magazines. It was hardly in there at all. There was an attempt by the people who sold zinc to show, excuse me, that steel can be used in houses, because to make a metal house with a metal panel, you have to galvanize the metal to make it, give it some durability. And the main component of galvanization is zinc. So people who were selling zinc wanted to sell metal houses. And they designed this house. Actually, they didn't design it, they footed the bill for it. It was designed by Rhode Island School of Design, and it's in Providence, Connecticut. And it was interesting, it wasn't, Rhode Island has an architecture department, but they didn't ask the architects to do it, they asked the industrial designers. So this was done by the industrial designers. Now this was done about 1973. In 1972, a very well-known book about the work of Jean Prouvé came out. Prouvé was a French architect who was very much working in that aesthetic of a kit of parts, whose elements had this kind of stamped out look to them, very similar if you know that work. And it must have been a case of the book opened on one side of the table and the drawings being done on the other, because the similarity is quite clear. What's interesting here is that it's not steel sticks. These are steel panels. What we'll see, in fact, let's see now. By the way, whoops. This house, this was a photograph taken when it was built in '73. This was a photograph I took about 6 months ago. It was never painted. That's the same color. Photographs can lie. Here's another example, though, of my premise that whoever owns a metal house buys a car the same color. Even if, depending on the way the photograph looks, they change their cars. Basically, what this is a small skyscraper. It's a steel frame. This might as well be the Wainwright building or the Seagram building, onto which these metal panels are placed. So at least it's not steel sticks. At least now it's steel post and beam. But it's still a wood technology. This could be a barn from New England. It's post and beam, just steel post and beam. And now the skin is steel as well. But it's clearly a skin. It's not a structure. It's not load-bearing. The panels are galvanized metals, which have special coatings on them and finishes. And there's foam inside. These are really composite foam panels. A sandwich of steel, polyurethane foam, and another level of steel. And in this case now, for the first time, this panel is the exterior surface, the insulation, and the interior surface. Not the structure, but at least it's functioning in those three ways. These are just some slides of Prouvé's work from the 60s, and you can see the stamped out metal pieces and the kind of designs, architecture that he was creating 10 years earlier. More in the European tradition of a kit of parts. The people at Rhode Island weren't thinking of selling that house design per se. They were really more thinking of selling that kit to which you would then make your own designs. The house was made of these panels. These were made by a company called H.H. Robertson, which is in Pittsburgh. And it's about a 2-inch panel, and they were bolted to the steel frame, as you can see on the right. Made for a very continuous skin. Now, 2 inches of urethane is decent insulation. By pre-energy crisis standards, not bad. What's nice about this technology is you can make that 4 inches and get very high insulation levels. And 4 inches is a nice number because nominal 4 inches is what the thickness of a 2x4 wall is. So you can make a thicker panel, cut openings in it, and put standard windows and doors. So that was an interesting idea. Inside of the house, in some ways, is quite clever. All the furniture is wood, because it's a metal house, they want people to think it's wood, so you make all the furniture in wood. You make all the details in wood. And you go in there and you think at first, this is a rather warm place. This doesn't feel like a steel house. Unless you look at the walls and you can see the seams. What you're seeing, the verticals are the steel structure which is clad in lead. The only reason it's clad in lead is because the zinc people also represented the lead people. So they had to find some uses for lead. The mechanical system is kind of interesting here. There was a module, a little module that, this actually is not the module, this is a closet module, but there was another module that looked like this one that was on the side of the building. This house was built with a pole foundation, there was no basement. And the ductwork would go from the module to the plenum, which was underneath the floor, and then they would spread out in different directions and then up from the floor. You can see the vent for the ductwork. All the electric was run along the frame, the steel frame, so all the outlets and all the switches are in those columns. Now, some of you must be asking yourself, how do you put up the pictures? And how do you put up the paintings? And you use magnets. And they're amazing magnets. They're very strong. And that's an example of one. Here's the seam. We found out subsequently that that's what Lustron people do too. All the Lustron homeowners have their magnets and they work. It's a wonderful system as long as you don't want to change the color of your house, because it gets to be a little difficult. This system was built in '73. I visited this about 6 months ago. It is brand new. You couldn't, looks like it's right out of the box without the batteries. Well, of all places, from Providence, Rhode Island, our search took us to Mexico. Because as we were looking at this history, we kept saying to ourselves, well, there's this magic panel, and these panels are nothing new. The composite foam panels are used all over construction. They're used in warehouses, they're used in commercial buildings for curtain wall skins. They're used everywhere. There's nothing new about it. But what's the point of taking that technology and using it as a skin in a small building? Why can't it be structural? Why can't those panels hold up the house itself rather than be plunked on a steel frame? And sure enough, as soon as you think of something, you can almost be sure someone else has too. And the people who thought of it were in Mexico. It turns out the Mexicans lead the world in steel prefabricated houses. So we had to go to Mexico. So I went to Mexico, went to Monterrey, and there's a company in Monterrey which for about 10 years has been making precisely these kinds of houses. It's the same foam panel, almost the same foam panel, made in, I'll show you the difference in a second, made in Monterrey and used for these very humble little houses, which are not bad by the Mexican standards, but they're made as structural bearing walls. For the first time, that panel is everything. It's structure, it's outside skin, insulation, the whole shebang. And you decorate it with a little brick. This is not even real brick. This is, kind of Z-brick pasted on there. Now, the quality control in Mexico leaves a little something to be desired. The joint is not nearly as elegant as the one in the American system. This is the Mexican panel. And on the right, we went to the building site and saw all these holes and said, what's the story there? And they said, well, that's where we put the electrical conduit. We don't want to, we have to run the electric somewhere. So we put a pipe down the center of the panel. We said, precisely the center of the panel. And that's what precisely the center of the panel looks like in Mexico. I couldn't help but wonder, actually, in the earthquake, these would have been the safest houses, because if they had fallen on you, you still wouldn't have been hurt. The way they work, their system, and the detailing is not that well advanced. But what they have is a bent metal connector piece, for want of a better word. And the vertical wall panel comes up into that, and then the roof slides on top of it. And then on either side of the wall, they run their electrical wires. And when they want to electrify a certain panel, they hope to find that conduit in the middle of the panel, and they cut a hole and they put the wire down. What is interesting about their system, though, is that they had the first continuous panel line in the world. Let me explain that. Up until about 1975, to make these kind of panels, the way you did it no matter what company you were, was you took a piece of metal, you squirted on urethane, and you took another piece of metal and you put it on the top, and you made it like an ice cream sandwich. But what they did for the first time was they made it a continuous line. They took coil steel. And you have to know a little something about steel here, but you know the big, huge, round coils of steel. And they put these together on a line, and they squirted urethane continuously. So they produced this like sausage, and they just cut it. And which makes it amazingly cheap, particularly if you have that kind of quality control. It's only in May of 1985 that H.H. Robertson, the biggest composite foam panel maker in America, put the same line in. Visited the factory in May. And their price went down, their in-house price. Not what they'll sell it to you for the same cost, but with their price to make it went down by about 2/3 in 1 month. So all of a sudden, there's a new material. It's you know when you first year architecture school, when you make your designs for houses and you show no structure, they're about that thick? This is the material you've been using. And it exists now for the first time. There is the hole for the electrical outlet. Hopefully you find it. And there is a little substructure. There is, in the case of long spans, there's a gable beam. And there's a lot of things I'm not going over in great detail here that I could be talking about the system. But I want to show you how we progressed from copper wood frames to steel sticks to steel curtain walls to steel structure. This is before we started designing anything. This is before. We subsequently visited all these places, but we found out about them all on paper first. We went to visit some houses. They have built several thousand of these houses in Mexico. These were in Manzanilla on the west coast. And this was on a marine base. These were marine housing. And while they're very rudimentary, there's the beginnings of a vocabulary, the beginnings of the suggestions of things you can do. And architecture is so wonderful because look at, they only made the panels in 2 colors. You can get the beige or the red. And in Mexico, it's hot, you know. So why would you want to put a red roof? If you had a choice between these 2 colors, why would you put a red roof there? Well, the answer is semi-obvious, which is because most of the roofs there are red tile roofs. So they had to sell red roofs, so this is the color they had to make. Whereas from a thermal point of view, a climatic point of view, it makes no sense. It just shows you how strong these cultural issues are. And I hope that will help explain the conclusion we came to later. But the last house I'll show you is this one. This is the Robertson house. The Robertson people, after seeing that house in Providence that used their panels, were not dumb people. They realized the same thing we realized. They said, why can't we take our housing system, take our panel and make it into a housing system? And they did build a house in Boulder, Colorado in about the same time, 1975. This is it. It's got a spectacular site, and they've never published this. This has never been published anywhere. You're seeing it for the first time. They kept it internal in their company because they thought it had such potential they didn't want anybody to know about it. And it was built in 75, although it has a nice kind of 1960s ranch look to it. Once again, like the Lustran house, my first look, I wasn't that enthralled. But as I went to the house and walked around in it and got to know it, I found it's amazingly clever, for reasons I'll explain. The plan is on the left. You know, in this case, you have the walls, the relatively short spans. There's a limit to how far this material can span. So you begin to have tripartite organizations rather than maybe the other kinds of organizations you have in some house plans. You also begin to have sheds rather than gables. And you have a situation where the architect took all the wet facilities like the bathroom and the washer dryer and the hot water heater and placed them in a central core and then framed that element in a different material because the very wet environment wasn't the best environment even for the coated steel panels. So there becomes an architecture that comes out of this product. An architecture of central cores, an architecture of certain dimensions, an architecture of certain roof pitches. And you find very quickly that it has an aesthetic. And as a first try, I think this did a pretty good job. If now it looks a bit dated, I think that's only because we haven't come around back to it yet, perhaps. The inside has that nice metallic reflection that you see in all metal houses. And what's interesting here is that beam at the cornice. It acts almost like cornice molding, but really it's the structure. It takes the system and makes it into a portal frame. You have very rigid connections between the panel and the ceiling continuously. So for those of you taking structures, you know that a rigid connection acts different than a non-rigid connection and different structural behavior. And so this is an unusual kind of structure for a house. It's more like a Butler building in some of the portal frames. The house is also as good as new. It's owned by the same people who owned it originally. They swear by it. Let's see what else I have here. What's interesting here is the way the panels just slide outside. It's kind of the Barcelona pavilion brought to suburbia. These panels just slide past the inside window. What you're looking at is that corner there. The beam becomes just a little trim piece. Very different than the Lestron house, which tries to hide the fact it's steel. The corner is met in a certain way with a trim piece. You wouldn't know anything special is happening. Here, it glorifies that kind of 2 or 3 inch, almost fake-looking material, that pulp board that we make our first-year projects out of. Here you can see, it's so thin. God, that's not what's going on in architecture today. Now you have stucco to look like concrete or look like stone. Here you have 2 inches of flying metal panel. So it was very jarring a year ago to start looking at these kind of buildings after looking at what's being published. And I've grown to be fond of them. Again, you fake stone stuck on the front. Some more interiors. There's really many details we can go over, but I don't have the time. Here again, when there is a hole, this case there was a plumbing line that was taken out of the building, and they wanted to seal it, so they would use car compound and just seal it up. In this case, all the electric and plumbing is on a peripheral kind of plenum at the base of the wall, so all the power outlets are at the base. There was no attempt to try to electrify the panel itself. Well, I'm sure that's a little hard to read, but let me just tell you a little bit about what it says. What we did was try to understand all these different cases, these houses we had seen. And we realized that really there was a matrix taxonomy that could be set up. We asked, what was the house structure? Was it wood or steel? And then what was the house skin? Was it conventional steel, and foam non-steel panels? And we set this matrix up, and we've subsequently found a house for every single box. In other words, if you can imagine it, someone's produced it. And in some of those boxes, many cases have been tested and tried, in other cases, very few. But after looking at all these examples, we concluded only a few months ago for Bethlehem that the one to pursue is this composite foam metal panel. Because we felt that while the panel had existed before, it's only in May that the price of this thing had come down to the point where it began to make sense. Something else had happened too, part of what you're seeing in your own building. Computer-aided design, computer-aided manufacture. For the first time, you can, and there are companies that can, take messages from the computer with automated braking equipment, automated metal fabricating equipment, and customize, or at least semi-customize, the cornice moldings, the trim pieces one needs to make the panel into a system. And now one can begin to design, market, order from the factory, use the computer to run the actual piece of equipment. It's going to make the details to make it a reality. And what we've done is we have the same equipment you have, and as we've begun designing the system, we've done it all on the Intergraph. So the client, the person for the house will be able to sit down at the terminal, call up their house, modify it. Instantaneously, you'll have a bill of sale. It'll have a perspective from 3 different angles. It will tell you the price of it. It will tell you the heat loss rate. It will give the elements to the factory so that the factory can put them on the truck. And we're actually doing that. We thought we were pretty clever. It's not a new idea. Many people have had it. But we were working on it fairly actively, and I thought we were doing a pretty good job until about 2 months ago. I made a trip to Pittsburgh to visit Robertson, the panel company, and Ryan Homes. Ryan Homes is the third largest home manufacturer in the country, and they're in Pittsburgh. And I walked in there, and I was very excited about telling them this thing we were coming up with, and they short-circuited me completely by showing me that they are already doing the same thing. When you buy a Ryan home, exactly that happens. They don't market it. You can't buy it off the terminal, but as soon as you buy it, the drawings, the deliveries of the routing of the elements through the factory, all of that is completely done on the Intergraph. All the documents are completely, they don't use paper anymore. Today, this is not science fiction. So they did me one better very quickly. But it did convince me that our idea was quite viable, and you may know that in Japan that it's also happening right now. We did come up with some other companies. I don't have time for them. There's Pond Hill is another company that's taking steel panels from a batch process and putting them on a wood frame. Ilsro put steel houses on steel frames. They're putting steel houses on wood frames. When we came up with that matrix, I said, who is going to put a steel panel on a wood frame? Nobody will do that. We found the company that did it. If you can think of it, someone's done it. Another company makes these bizarre steel framed houses. They seem to be primarily involved in selling distributorships. But we are, this is not the system, this is just a house. We have Intergraph like you folks, and we're applying it to our studies. Well, let me tell you a bit about what we've concluded and why it has something to do with these buildings. On the left, you have Norman Foster's kit of parts for the Sainsbury Center. And on the right, you have Richard Rogers' the Imos factory in Wales. Both architects who are working within this vocabulary of a kit of parts in the old Gropius tradition. What we concluded in looking at the designs, and looking at these houses, was that a kit of parts was not what we wanted. What we were looking for was a kit of forms, and we see it as a major distinction. We think that Lustron was closer to the way it has to be. One has to not design an optimized piece, not an optimized panel or an optimized connection, but one has to design the forms. There are certain elements which make a house, which turn a rectangle or a cube into a house. Dormers, bay windows, porches, vestibules. Those are the elements of houseness. So we went to them and said, look, don't worry about optimizing these connections. Worry first about making these elements. In Lustron's house, and I should have pointed out to you at the time, some of those bay windows like the awnings and so forth, those are formal pieces, little pieces that you could snap onto the house. And what we said to them, you have to start not with a kit of parts, but a kit of forms. And that somehow there has to be enough variety in these forms to appeal to an enormous range of people. We were also saying to them things about the durability of the material. Don't worry about that. We know that there's problems with the longevity. There's also new coatings. We're looking at new marketing systems and so forth. But architecturally, we had to get these people who are interested in thinking about products. Robertson, Bethlehem, these are companies that make products. They don't make houses. That's a new industry for them. So we had to get them to think about making houseness elements. And that's the battle we're having right now, as a matter of fact. We're just drawing to an end of our first year with them. We have a bunch of very specific proposals, some of which I'm not even at liberty to tell you. They hope to make a proprietary product out of it. But it's been very interesting to us to see how, in a sense, what started as an element of the international style, this idea of kit of parts, which made sense in a time when history was not being looked at, when eclecticism, when historicism was not very important. That theory made sense. But now we're in an age when we're willing to look back. We're willing to learn from those elements, those orders, those forms. And what we're saying is we have to rethink what prefabrication is and see it as a kit of forms. So that might help explain my introduction. I think that architecture is about looking at the past in this way, or even further, and then seeing what the opportunities are in the future simultaneously and trying to find some agreement between the two in a new product. So maybe a year from now, if you invite me back, I'll show you what our houses look like. Thank you. If there's some questions, I'd love to try to ask them. Yes? The first question was, how do the metal panels handle sound? The biggest issue in sound isolation is the weight of the interface between rooms, and also the fact that you want to make sure there are not acoustical short circuits between rooms. Basically, a 1 foot square piece of metal panel weighs almost the same as a foot square piece of wood wall with gypsum on it. So its acoustical properties are not that different. In the metal houses I've been to, most specifically the Boulder house, the Robertson house in Boulder, they claim from living there 10 years that there's no acoustical problems. They say, in fact, that it's better than most houses. But that's something we are looking at. It's an issue for sure. I was there when it was raining, and the sound of the rain on these panels was quite mesmerizing. It was like a thump. You think it might be a pitter, 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 but it's not. It's more of a thump, 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 thump. It's kind of nice. And what was the second question? Terrible. Yeah, it was a silly idea. We would never do such a thing. Number of problems in the Lestron houses, as there are in all these houses, and necessarily had to gloss over many of them in the course of making a summary history. And they're real. But most of them are not endemic to the idea. They're things that can be solved if they're thought about ahead of time. The Lestron house, if you have a chance to visit a Lestron, you should. It's really quite interesting. We're going to be publishing the Stoneroff house, the Boulder house pretty soon. We're not sure which magazine, but Fine Home Building wants to do articles on these houses. The biggest problems I've seen, and the question was again about condensation on the Lestron. The biggest problems I've seen in Lestron was in the bathroom areas, in the kitchen areas. And in something like the Boulder house, the solution is simply to isolate those in elements that aren't steel panel construction. And I think that steel is still a corrosive material even when you treat it. I mean, it only goes so far. There's new coatings like Galvalume, a new proprietary product by Bethlehem, which can solve some of those moisture problems. But I think it's partially a design problem. Yeah.
What's the estimated life expectancy of these homes?
Well, there's two separate questions. The question was the life expectancy of metal homes. There's two separate problems. One is an aesthetic problem. It looks like hell when it rusts. And the other is a structural problem. Is it going to fall down? It would take a long time for it to fall down, but it might look bad. So the question is, at what point do you put your aluminum siding on your steel house, I guess? By then it'll be vinyl siding, I suppose. Because at some point any house, any surface needs to be renovated. The question is when. They're all good questions. I'm proposing this as an idea, not as a fait accompli. I'm also presenting it as an architect, not as a material scientist. One of the nice things about working with a company like Bethlehem is you can go to them and ask the same dumb questions. And they have teams of scientists who will give you very complicated answers. But what we were trying to do for them was show them. See, they came to us with a rather naive idea about using steel in houses, and we tried to explain to them through this kind of analysis and looking at the history of architecture that they really wanted a product. They wanted something, that looked like that they could sell. Maybe 6 or 8 things, and they wanted a kit of parts. They thought that they could sell pieces, and they didn't want to hear what we had to say really. But we said to them, no, you have to sell houses. There's something very special about a house, and as a consequence, they're becoming a little less interested, but H.H. Robertson and Ryan Holmes are becoming a lot more interested. So we might find our client shifting any day now. One of the wonderful things, too, about this is that it's a great architectural design problem. As I said at the beginning, it's such an out topic. When anything is so out, it makes students excited. They know there has to be some merit if none of their faculty members know anything about it. So as soon as we talk to students about this, they immediately begin designing these new metal houses, and it's fun.
What are the price advantages of this type of construction compared to the wood-based skin, stress skin, foam core stuff now?
The question was about the cost versus stress skin wood. It's much better than stress skin wood. According to our numbers, which are pretty good because we went over them in detail with Ryan, these are not, these are pretty strong numbers. It's better than wood frame for exterior walls, not for interior walls. Because interior walls, you can't justify the insulation. There are also other problems. But the trouble is it's only a little better. It's maybe a dime per square foot better, or 20 cents a square foot. The average house has about 2,000 square feet of exterior surface. So what's that? 200 bucks. It's hard for a lot of these companies to get excited about that, particularly when, you know, if the price of wood drops or the price of gypsum drops. But if you happen to make these panels, you can get pretty excited about that. So there's a lot of steps. I love, Indiana is, of course, well, I don't know if it's of course, but you may know that some of the larger mobile home and prefabricated home companies are in Indiana, so some of you may have had a lot of firsthand experience. If you have any wonderful ideas, let us know. We'll put your name on the work. Yeah. Yeah. The question was, did we work? We looked at, I think, the obvious things to look at. The thing about Ryan, I should have pointed out, what they do is, and they're somewhat typical. I can tell you a little bit more about, we've proposed a little bit more than I've said. What Ryan does is they take panels, house panels, exterior walls, and manufacture them in a factory. And then they fabricate three-dimensionally the bathrooms and kitchens. And they put them on 2 trucks and take them to the building site. So you got one truck has got the three-dimensional elements, and one truck has the two-dimensional elements, basically. In one day, they then fabricate the whole house. What we're saying is that's exactly right. As opposed to, say, Japan, where most of the prefabricated home companies are only manufacturing three-dimensional elements and moving air across the roads. When you manufacture three-dimensional elements, basically what you're shipping is air, which is a kind of a silly thing to ship. So you only ship air when you have to for the high-tech elements, the bathrooms and the kitchens. So what we said to Ryan is, look, you doing three-dimensional cores already with a different product, that's great, just keep doing it. We'll just sell you different walls, different panels, which was, again, what we didn't expect to find, because Bethlehem thought CAD-CAM, Japanese companies, Sweden, they have these big robotized factories, will pump out these three-dimensional houses and ship them to the site. We came back to them and said, no, it doesn't make sense in America. Things are too far apart. We can't ship air here. You can only ship air in special places. So they didn't necessarily want to hear that either. But as you get into it, you find out all sorts of interesting things. And I also found out in general that we're much closer to the kinds of ideas than I realized about prefabrication than we were. What hasn't been thought through is the architecture of it. It really hasn't. Again, my trip to Ryan was an eye-opening experience to me because they have an architecture branch, but they don't call it the architecture, they call it product development. They don't design things, they develop products. They don't redesign, they rejuvenate. So I said, what are you working on? He said, well, we just rejuvenated 16 houses. I didn't know what they meant. I didn't know if they were, painting them or what. But what they meant was they redesigned them. But they won't use the word design and they won't use the word architecture. They deal only with products. And there's pros and cons to that. From a marketing point of view, it helps them understand what they're doing. But from an architecture point of view, it's a real problem. Up there, you think? No? Down here? Okay, thank you.